Hello everyone, let us study the cells in parallel so that we consider the three cells which are connected in parallel like this. Let the EMF of the cell be E and E. What does this mean? This means that the EMF of all three cells are same. Number one point is that one. Similarly, we know that there is internal resistance of each cell, which say small letter r, and small letter r. What does this mean? It means that the internal resistance of all these three cells are also same. If it is 1 ohm, then this is 1, 1 and 1. Every one is 1 ohm internal resistance. So let us now consider the external resistance which is connected to this combination of cells. Okay, so the external resistance be this one. So this is my external resistance, say capital R, in which there is a potential difference which is equal to say V. Right? So this could be anything. This could be an electric bulb. This could be an electric bulb like this resistance, or this could be an television, anything, or this could be any torchlight, etc. So let us see what will be the EMF of this system. So that is my total EMF. So I will write total EMF, okay, is equal to, so we know that there is a flow of current in this circuit from positive terminal to the negative terminal of the cell. So this is positive terminal, everything, the long is my positive terminal and this is my negative terminal, and we know the current flows from positive to negative. So this is the direction of current, isn't it? From this is A and this is B. From A to B there will be a flow of current. At the same time there will be a flow of charge, and the flow of charge is opposite to the direction of current. Okay, there will be a flow of electron. So this electron is flowing in this direction, that is E. So the electron is flowing in this direction. Now let me consider one electron which is giving us the current which is flowing from this. So the electron is coming and it has to do work. Okay, it has to perform work because there is an EMF. What is EMF? Electromotive force, which is also a potential difference. Electromotive force is not a force, it is also a potential difference. So in this potential difference, electron has to do work in this direction, and this work, say it is coming from this side, it is reaching and it will go in this direction. So let the work is say 3 unit work it is doing. Okay, how much work? 3 unit work. Now if I consider another electron in this path, then it will also come. It only come from this cell. It will not pass through this cell, and it will not pass through this cell. It will only pass through this cell. And how much it will do the work? It will also do the work 3 unit. Why? Because the EMF of this cell is also same as the EMF of this cell. It is E, this is also E. So again I will consider another electron which is flowing in this branch. How much energy, how much work it has to do? It has to do 3 unit work again. Why? Because the EMF of this cell is also E. All the EMF are same. It means that the net work done by each of the electron is 3 unit because of the same EMFs. That means that the total EMF is equal to epsilon, because this is in parallel. Okay, we know that in parallel the potential difference is same. So why the potential difference is same? Because of the work done is same. Okay, work done is same, therefore the EMF is also same. Potential difference is same because the work done by the electron here, here and here all are same. That is why the net total EMF is E. So we got the total EMF. Now, how many internal resistance are there? 1, 2 and 3 internal resistance are there. So what is the total internal resistance in this combination? So the total, okay, total internal resistance. So total internal resistance in this combination will be, say, 1 by R total is equal to 1 by R plus 1 by R plus 1 by R. We have derived this in parallel. These are in parallel. So in parallel, the total resistance 1 by R is equal to how much? 1 by R1 plus 1 by R2 plus dash. But here all the resistance, internal resistance are R and R. So I don't need to write R1, R2 and R3. Now if I add all these, if I add this, what do I get? Or R of total, this is R total, will be equal to how much? 1 plus 1 plus 1 is 3 divided by R, or this will be, let us do the multiplicative inverse, ulat pulat. So if I do ulat pulat, this will become R total will be equal to, this will become R divided by 3. Why 3? Because how many EMF are there? How many cells are there? There are 3 cells, therefore there are 3 internal resistance. So I got here 3. Now for n numbers of what? Cells. What will be the total resistance, internal resistance? The total internal resistance, okay, this small letter R is total internal resistance, will be how much? For 3 cells, it was R by 3. And for n number of cells, it should be R divided by n. Okay, so we got what? The total internal resistance. So the total internal resistance, how much we got? The total internal resistance we got, R total is equal to how much? I got R divided by n, and this is for n number of cells. Now let me find the total resistance. What I mean is that here is 1, 2 and 3. So we got the total internal resistance R by n for n number of cells, right? Now if we see here, what is there? There is one more external resistance. So this is my external resistance EXT. And how much will be the total resistance of the system? So if I do this, I have to have this internal resistance and this external resistance. If I add all this, then I will get the total resistance of this circuit. Please remember, this is the total internal resistance. This is the total internal resistance. Now I have another external resistance connected in this circuit. Then I have to have the total resistance of the circuit. So let us calculate. So the total resistance, or just write equivalent resistance, okay, of the system is equal to R equivalent is equal to how much? Total internal resistance plus external resistance, right? So R equivalent of the system is equal to, how much is the total internal resistance? The total internal resistance is this, we got, this is R divided by N plus how much is the external resistance is REXT. So this is REXT. So we got this one. Everything is now in our hand. So we got R equivalent is equal to R divided by N plus REXT. So this is R and this is EMF. Everything is done. Now we know that, let us find the current, and we know that V is equal to IR. And what is V? The potential difference. And what is potential difference? And what is E? Is EMF, which is also a potential difference. So instead of V, I can write E is equal to I into R. And how much will be the I? Then I is equal to E divided by R. Okay, you bring this R downward here, you get equal to I. So I got the value of I. So let us find the current. Okay, here current. Current I is equal to how much? E divided by R is there. So this is my E divided by R. Right? And this is which R? This R should be my R equivalent. R equivalent means all the resistance of the circuit. Then I will be equal to how much? This is E, that is E is the total E, no problem. Then divided by R equivalent is small letter R divided by N plus R EXT, that is external resistance. Now let us solve it. Then it will become epsilon divided by this N. I will take the LCM, this R plus it will become N into R EXT whole divided by N, isn't it? Taking the LCM, then this will become how much? This N will go here, then implies this, it will become I is equal to this N will come here, this will become N epsilon, that is NE divided by how much? This R plus N into R EXT. So we got the equation of current. How much is the current then? We got the current I is equal to N epsilon, that is EMF. This is R plus N EXT. So this is the equation of current in this parallel combination of cells. Now let me go to the some conditions first. So let me write case 1. Case 1. Okay. In case 1, I will write when R is much greater than N into R external. What does this mean? This means that the internal resistance is much greater than the external resistance. What will happen? Then I will get I is equal to, this is N E divided by R. Why? Because if it is very large, R is very large and R external is very small, then this R external can be neglected. So this will become 0. So I will write plus 0 and I don't need to write plus 0. So I got this one. So next, I will not explain the importance of this now. Next I will do first case 2. When, very simple, R is much smaller than N REXT. It means that this internal resistance are very smaller than the external resistance, isn't it? R small letter is much smaller than R external. So then what will happen? Then this current I is equal to how much? There is N into E. N into E divided by, I will neglect the R because this R is very small. So this will be N R EXT, and you know that this N and this N will cancel. This is by E by R EXT in parallel, isn't it? This is in parallel. Now if I do now one more thing, okay, so this is parallel. So if you see in these two cases, what is happening here, the current I is equal to E by REXT. Okay, so E is the total EMF and REXT is the external resistance. So if I do it for I for single, okay, I single means if I consider only one cell and the external resistance, then what will happen? In this N I will get 1 into AE divided by, I have 1 R, so I will write 1 into R, this is equal to 1 get cancels, I will get R by R. EXT, of course, EXT, and this is for single. What does this mean? This means that if the internal resistance is very small, then there is no change in the current. For n number of cells, I got E by REXT. For one single cell, I got E by REXT. It means that when the internal resistance is very small, there is no change in current. No change in current. When the internal resistance is very small. But the very important point is here. If the internal resistance is very large as compared to the external resistance, then what will happen? There is N, okay, and means the number of cells. If the number of cells is 1, it will become E by R. If the number of cells is 2, then it will become 2 E by R. If the number of cells is 5, it will become 5 E by R. What does this mean? In each step, the current is increasing. Okay, so current increases. Current increases. This is very important when the internal resistance is larger than the external resistance. So we concluded the two cases. Okay, in next lecture we study the Kirchhoff's law. Thank you.